So beginning chapter 3, section 1, we are further getting into what linear equations are, and especially what they look like on a graph. Definition of a linear equation is simply an equation that creates a line on a graph. So, you may remember what a linear equation is by something called y equals mx plus b. If that looks familiar to you, that's good. If it looks a little bit foreign to you, then we'll have to review a little bit. Y equals mx plus b is something called slope-intercept form. We'll get into that much later in the next few sections. Now, there is also a different form called the standard form. And what that looks like is ax plus by is equal to c, where a, b, and c are all going to be numbers, okay? So if you look at this example right here, this example 3x plus 2y is equal to 5, that's written in standard form. And the a is just 3, b is 2, and c is 5. So if you see right above that example, I wrote the standard form. The variables x and y just kind of stay the same. So linear equations can be written, have an x and a y variable, okay? Now the way to identify linear equations, meaning determine if it's a yes or a no linear equation, can be followed by these three guidelines. So number one, there can be no exponent in the equation which is greater than greater than 1. Number two, it can be written in the standard form, ax plus by is equal to c. And then number three, no term has more than one variable. So if you scroll to the bottom, we're going to get to a couple questions about determining whether if each equation is a linear equation or not. So the directions say, determine whether each equation is linear, write the equation in standard form. So there are two things. Number one, we have to say yes or no. Number two, if it's a yes, then write it in standard form. Now, if we look at the criteria, and if you scroll up, I can't do that right now, but you just got to ask yourself these three questions. Okay, looking at letter A. Number one, are there any exponents that are greater than 1? No, no exponents. Okay, so far so good. Number two, can it be written in standard form? It can be written in standard form. Let me get to that in just a sec. Number three, there aren't any terms or any of these three groups here that has more than one variable. So this is yes. This is yes, it is a linear function. Now it says to write it in standard form. So I'm going to rewrite my equation here. Now, y is equal to 4 minus 3x. What my goal is, I want it to look like where my x and my y are both on the same side, and then I just have a random number by itself. So right now, if you look at this line here, my x and my y are on different sides. So I'm going to move this x to the other side, cancel it here on the right side, and then on the left, I end up with 3x plus y is equal to 4. And so if you notice, this very much looks like my ax plus by is equal to c. In this case, my a is 3, my b is 1, and my c is 4. So a is 3, b is 1, and c is 4. And so yes, it can be written in standard form. So let's look at letter B. Determine whether if this equation is a linear equation. Okay, number one, there is no exponent that's greater than 1. Number two can be written in standard form. Maybe it kind of looks like ax plus by is equal to c. But actually, number three, it says no term has more than one variable. This term right here has an x and a y. So this is no, not a linear equation. Okay? So why don't you take some time and just see if 1a and 1b, if those are linear equations or not. And then if it is, then you need to change it so that it's in standard form. Number one is yes. I don't have any exponents that are bigger than 1. it can be written, even though the x is not there, it's kind of like there's a 0x plus 1/3 y is equal to -1. And so it is possible to have a 0x. And then there aren't any terms with more than one variable. Now, there is also one thing that I forgot to mention about standard form. So if I wanted to make sure standard form ax plus by is equal to c, the numbers here, a, b, and c, cannot be fractions. So what that means is, since I have a fraction here, how do I get rid of that? If I multiply this whole thing by 3, okay, 3 times 0x gives me 0x still, plus 3 times 1/3 gives me 1y, or just y, and then 3 times -1 gives me -3. So now you'll see I have all these whole numbers, and once you get rid of this 0x, y equals -3. That's written in standard form. Go ahead, try letter 1b. You'll notice right away that there is an exponent that is greater than 1. That breaks our rule, so no, this is not linear. If that didn't make sense to you, maybe 1a didn't make sense to you, pause the video, go back to it and rewatch it now that you're done writing down the notes, and maybe just rewatch it. Otherwise, I'm just going to kind of keep going with x-intercept and y-intercept. X-intercept is when your line or the linear graph crosses the x-axis. And in the same way, the y-intercept is when the linear graph crosses the y-axis. So if you look at this fake graph on the right, you'll see that here, when the linear graph crosses the x-axis, that's my x-intercept, and where it crosses my y-axis, that's my y-intercept. So those are our x and y intercepts here. Now, if you kind of scroll down, we're just going to kind of evaluate or interpret what some of these graphs are saying. So this is a multiple choice. It says, find the x and y intercepts of the line graphed at the right. Maybe with a pen or with an iPad pen, highlight where the y-intercept and x-intercept are and label them. So there are my y-intercept and the x-intercept. And then, since this graph actually has a number, the x-intercept here is at 20. And so right away I can eliminate A and D. And the y-intercept is at 30. And so B is my x-intercept is 20 and y-intercept is 30. Let's scroll down a little bit to keep going. Number 2 says, find the x and y intercepts of the graph. Go ahead and circle F, G, H, or J based on the gym membership graph. So you'll notice there, that's where your line crosses the y-intercept, but this is a horizontal line, and if you think about it, it's going to go on forever and ever and ever. There actually is no x-intercept. And so my y-intercept is at 150, and so it's definitely not G or H, but there actually is no x-intercept, so J is my correct answer. Now, so that's finding intercepts, x and y intercepts from a graph. And now we're going to look at intercepts from a table. Okay? So if you look at this table here on the right, it says the swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time in hours that the pool has been draining. And so if you look, at time 0, we start off with 10,080 gallons. And then in 2 hours, we went down a little bit, so 8,640, and then in 6 hours, and so on and so forth. Find the x and y intercepts of the graph. I want you to kind of pause the video and circle the pair that shows you your x and y intercepts and then label them. If you circled these two, then that's good. okay, what you'll notice, what you're looking for is, in the table, you're looking for zeros. When x is 0 and y is 10,080 gallons, this is going to be my y-intercept. And then when x is 14 but y is 0, that's going to be my x-intercept. Because if you think about it, then that graph will look like what's on the next page. You'll see here on the graph, the table, it said that my y-intercept was 0, 10,080 gallons. That's right here, my y-intercept. And then after 14 hours, that's my x-intercept. That means if I, that's my x-intercept. And so letter B is asking, now let's bring it back to the story. Describe what these intercepts actually mean in this situation. So what I want you to do is make a conjecture on what does the y-intercept mean in the story and what does the x-intercept mean. The y-intercept, what it means is that at 0 hours, I started with a tub or a pool with 10,080 gallons. And then the x-intercept, what that means is it took 14 hours for the entire pool to be completely drained. So that's what that means. Now, we're going to get into graphing using x and y intercepts, okay? So graphing is very related to algebra. Now, if you remember from, if you just kind of recall from the problem that we just did, the x-intercept is where the line crosses the x-axis. So the point is going to be x, some number, comma 0. Could be -3, 0, 8, 0. But what we know is always comma 0. And then the y-intercept is always where the line crosses, and so you get 0, y. Okay? Now, that is heavily related to how we're going to use this for algebra and how we're going to use this for graphing. So this first one, it says use this equation 2x plus 4y is equal to 16 by using the x and y intercepts. They want just 2 points, okay? The x-intercept, they want x, 0, and then the y-intercept they want is 0, y, okay? Now, I'm going to rewrite my original equation here. 2x plus 4y is equal to 16. If I want to find my x-intercept, I'm going to plug in x for x, and then I'm going to plug in 0 for the y. Because of the fact that x, 0 will give me the x-intercept. Now, 4 times 0 just gives me 0, so I'm just going to get rid of that. And so I get 2x is equal to 16, and then just divide both sides by 2, and I get x is equal to 8. So my x-intercept is 8, 0. Now, in the same way, my y-intercept here, I'm going to rewrite the problem. I'm going to do the same thing, only now I'm going to replace x with 0 and y with y. Until this time, the 2 times 0 cancels, and I end up with 4y is equal to 16, divide both sides by 4, and I end up with y is equal to 4. So that means that my y-intercept is 0, 4. Let me label these. So what did we just find? We found 2 coordinate points. So 8, 0, okay, so it's going to be, if I were to extend this, 7, 8. That point's going to be right here, my x-intercept. And my y-intercept was 0, 4. So 0, 4 is way up here, and then I'm going to connect these points. And that's my linear graph. That's my linear graph based on finding my x-intercepts. If you didn't really get that, you could pause the video and rewatch it, but we will go through a couple extra practice problems a little bit later. Now, let's move on to using a table. So they want a completely different graph. Y is equal to 1/3 x plus 2. Anytime, you could always graph using a table. So you need an XY table. And you can just pick, I usually pick about 4 or 5 x values, random x values. And then using those x values, I figure out what my y values are after evaluating them. Now, normally I would pick like -2, -1, 0, but if I pick -2 here, I notice I have a fraction, and it's being multiplied to the x. So I got to think about what would be some good numbers to choose for x that's going to be multiplied by 1/3. If you thought -6, -3, 0, 3, and 6, that might be good. Why did I choose those? Because when I plug in -6 for my x, you'll notice that 1/3 times -6 gives me -2. So y equals -2 plus 2. And so y is equal to 0. And so when I plug in -6, I get a y answer of 0. I'll go ahead and plug in these other 4 numbers and see what you get as your value for y. So you'll notice I got 1, 2, 3, and 4 when I plug in those numbers respectively. And then you just got to graph it, right? Because these are just coordinate points. -6, 0 is all the way here on the left. And then plot the other points. So I have my 5 points, and I'm just going to connect these points here using a line, drawing a line. So that's another way to graph it. If you notice that this is actually my y-intercept, and this is my x-intercept based on the graph. This is my x-intercept, and this is my y-intercept. So all of these are so connected. Algebra with a table with the graph. We're going to jump down to the next page. I believe this is the last page, and we're just going to practice. We're going to practice using x-intercepts and y-intercepts. I'm going to change these directions here. It says graph each equation. I'm just going to cross this out. Okay. What I would like you to do is, I would like you to graph this one by using the x-intercept and the y-intercept. Okay? That was like the example done above. Let's go ahead, pause your video real quick, and try to remember what we did for the x-intercept and the y-intercept. If you remember, my x-intercept is going to be some number x, 0, and then my y-intercept is going to be 0, y, some number y. And so those are the numbers that that's what I'm going to plug into the equation 2x minus y is equal to 2. So for example, my x-intercept, I plug in x for x, and then I plug in 0 for the y part. And so since just 0 is nothing, then I end up with 2x is equal to 2, divided by 2 on both sides. I get x is equal to 1. And so my x-intercept is 1, 0. And try plugging it in for the y-intercept. After you plug in 0 for my x and the y for my y, I solve it. Don't forget about this negative right here that gets carried down to the bottom there, and then divide both sides by a -1. Then I get y is equal to -2, which means my coordinate point is 0, negative 2. And so 1 comma 0 is over here, and 0 comma negative 2 is right here, and then I'm going to go ahead and make a line that cuts across both. And so that's how we use the x and y intercepts. Okay. What you'll notice is, for the next example, x is equal to 3, and there's no y, right? But again, if you have it in standard form, x plus 0y is equal to 3, that just means no matter what number you put in for x, you're always just going to get, and it doesn't matter what you're going to get for the y. And so what that means is, this is just always going to be 3 comma something, 3 comma 7, 3 comma 8, 3 comma negative 2, 3 comma negative 1, because no matter, even if I put a 7 into here, 0 times 7 is 0, so I'm going to get x equals 3. If I put an 8 into here, 0 times 8 is 0, so x is going to equal 3, and so on and so forth. It doesn't matter. So this is actually going to be a vertical line if you plot these points. No matter what y value you pick, you'll notice that you're always just going to get this vertical line here. Okay. Y is equal to 2. Negative 2 is the same thing, only it's a horizontal line. You know, I'm gonna cover these in a little bit. What I'd like you to do is, I want you to change this to y is equal to negative 2x plus 1, and I want you to practice using a table to plot your graph. Okay. And then choose numbers like negative 2, negative 1, 0, 1, and 2. A lot of students ask me, where do I get these x values from? I'm just kind of making them up. These are just numbers I'm plugging into this equation, and then I'm just seeing what y values I get. So plug those in and see what y values you get. So you see that I plugged in the x values, which are all in blue, and then after I did the math, I got all my answers, which are all in red. So I have negative 2, 5, negative 1, 3, 0, and I'm just going to go ahead and plot those points. And so you'll notice that I have that line. If any of this video, I know it was a long video, okay, but rewind, pause and rewind, rewatch it if you need to, but this is just the section of, there are so many different ways to graph a straight line through x-intercepts, through a table, and then we'll eventually figure out how to do all these things without those things. Alright?